there's another automatic feature you can get, or you get for free. Whenever you create a service, there's also a internal DNS name. So in this case of our service, it is a service that also has an IP address. And this IP address is fixed. As long as the service exists, you will get exactly this IP address. But I'd also like you to show, I also like to show to you that there is no alternative way to that. So we do ns lookup. Oops. And we take our service name. We take our service name, the namespace, SVC for service, and the cluster domain. So the cluster domain is an internal IP address that can be configured in a Kubernetes cluster. Per default, it is often cluster.local. Different Kubernetes cluster could have different cluster domains, but in this case, it's cluster.local. So service is always the same if we want to refer to a service. Then you have the namespace, which would be Knative tutorial, or is it Knative training? Kubernetes training. Oh, let me check. I think it's Kubernetes training. Is it? Yeah, Kubernetes training. So this is the cluster address, the cluster URL. This is always the same if you're referring to a service. This is the namespace, Kubernetes training, and this is the name of the service. And if we look it up with NSLOOKUP, you'll also resolve to the IP address. So if we curl that URL on port 8080, you also get the same reply. So the takeaway here is that the name of the service makes up this URL. Whenever there's a service called Simple Go Web, this domain will resolve to the IP address of the service, and the service will be a reverse proxy to your application. Now let's delete the service. And obviously that can't resolve anymore. But we want the service, so we recreate it. So look what happened. Look what happened. Although the IP address of the service remains the same and decouples from the changes of the IP address changes of the pods, because the replica set could do self-healing, or for other purpose you scale up, you scale down, or you deploy a new replica set because there's a new version of your application. There will be IP address changes of the pods for sure over a longer period of time. Therefore, we concluded it is not safe to use the IP address of a pod to refer from one application to another. We went to the service. We've seen that the service now has its own lifecycle, which is independent from the replica sets. This is an advantage. So whenever the replica set changes, or the pods of the replica set respectively, the IP address of the service remains the same. So one could think, oh, I can use the IP address of the service. Well, yes, you can. But if for whatever reason, for example, because you changed the Kubernetes cluster with your whole deployment, the IP address of the service changes, or because you accidentally deleted it, or because for whatever other reason you have to recreate the service, the IP address of the service will change and you'll have to adapt the application. And adapting the application does not necessarily mean code, because if you put IP addresses in your source code, well, yeah, all ideas I now have are swearing, so you shouldn't do that. So you definitely create something like a config map, which we'll cover in a future tutorial, where you can store configuration values. But even in this case, you'll have to touch the config map, and you may have to restage the application and so on. So this is not the way to go. If you instead use the DNS name here, this one, this will remain the same, because even if you recreate the service somewhere else, it will always create the same DNS name internal to the cluster. And this one stays the same, unless you go to a cluster where the cluster domain changes, to be fair. But it gives you much more control over the connection between two applications. Now, you could ask yourself, where does this DNS thing come from? And this is a pluggable. There's a Kubernetes DNS standard. And in this case, if you do kubectl get pods, and I'm now asking the kube system namespace. Oh, I'm within the pod. That doesn't make sense. Kubectl get pods. Then you can see that there's a core DNS running, and this is basically where the magic happens. So whenever you create a resource, such as a service, it registers automatically a DNS entry for the service. And this provides you with stable network identities as URLs, and you can use these URLs. So how would you create two applications where one application talks to another? You would create a service for the service you want to talk to. You will connect the service to the backend or the endpoint, the pods of the replica set, for example, or the deployments, basically the same there, by ensuring that the label of the pods, not of the replica set, not of the deployment, the labels of the pods, they need to match the selector of the service. So again, this selector here, this needs to match this, not this, but this. All right? Good. So we have seen how to create a service. We have seen that the service has its own IP address. We have seen that the IP address of a service changes if the service is recreated. But we have seen that the most stable identity of the service is its DNS name within the cluster, and that this provides us a simple utility for performing service discovery, so that one application can connect to another application by its service name. We've also seen how it looks like if no endpoint is available, because the services selector does not match the application's label. We see that no endpoints are available. We have seen how to debug this. We described the service, we've seen and confirmed there are no endpoints. We've compared the selector of the service with the label of the pods, not the replica set, not the deployment, and ensured that they'll match. Once they match, and this happens immediately, or nearly immediately, the endpoints of the service are there, and you can resolve and you can access. We've also seen how we can use kubectl proxy to use a service, although the service is internal to the cluster and is not exposed to the outside world. via a public URL. We can use the kubectl proxy with our reverse proxy using a localhost domain that's been built systematically and is functionally dependent on the name of the service to reach out to the service. We've also seen how we can use a utility pod to curl a command and also access our service. This is good because during a more complicated deployment, or during your final exam, for example, you may have an application and a service already, but not yet an ingress. Or you may never want to expose a particular service, but yet you would like to do a curl command and see whether the service works, or just do a short request to obtain a piece of information. And this is possible, like demonstrated in this lesson.